Hi, we're continuing with life science and cell biology in a nutshell. Um, so, Earlier we were learning about the membrane of cells and what they're made of. Mostly they're made out of phospholipids. Um, in this diagram, you can see the bilayer. So, there's two monolayers. They each face one another. So in the light pink, you can see the fatty acid nonpolar tails of the phospholipid molecules. Um, okay, this is actually two sets of bilayers. So, and the reason is that in bacterial cells, there's two membranes in the surrounding the cells for increased support and integrity of the bacterial cells. But normally, eukaryotic cells have just one bilayer surrounding cells, which comprise the cell membrane. So the kinds of molecules that comprise these membranes are shown here. So again, in the red, you have the polar heads of the phospholipid bilayers, which are made of a phosphate group, an alcohol group, and the glycerol backbone attaches this polar head to the fatty acid tails, which are nonpolar, the light pink. So those are the the phospholipid molecules. So here it says outer lipid bilayer, inner lipid bilayer, and periplasmic space in between the layers, lipopolysaccharide. So these are lipid bound to sugar molecules, polysaccharides. A lipoprotein is a lipid bound to protein molecule. There's also molecules called porins. That's a channel for letting molecules go through. It's a protein channel. So peptidoglycan, so proteins bound to sugars or carbohydrates. Shows an example of a soluble protein in the periplasmic space that goes through the channels, and a transport ATPase molecule. So the transport channels, which use energy from ATP in order to let large or insoluble molecules, large polar molecules, which don't go through the membrane easily, they go through channels. And especially if they're going against a solubility gradient, concentration gradient, they will use ATP energy in order to move across the membrane from higher concentration to lower concentration of that molecule. Okay, so here they're showing the four different major phospholipid molecules predominating in the plasma membrane of the mammalian cells. First shown phosphatidyl, or choline is right here actually. Phosphatidylamine, serine, and sphingomyelin are the four major mammalian phospholipids. So phospholipids are all the same in that they have a fatty acid tail, glycerol backbone, a phosphate group, and um, they have polar head groups, which are different between the different phospholipid molecules. As you can see, um, so these are also called alcohol groups. So phosphatidyl ethanolamine has an NH3 group, two CH2 groups, so they all bind via an oxygen and a CH2. It looks like, and then phosphatidylserine is a carbon, hydrogen, carboxyl COO and group, and NH3 as well. And then phosphatidylcholine is a CH2, and then three CH3 groups with the nitrogen in the middle of the four carbon groups. Then sphingomyelin looks very much like the choline. So okay, so in sphingomyelin, it looks like the fatty acid tail has a nitrogen and an NH instead of one of the oxygens. It has a CH instead of another second hydrogen. So each tail is slightly different, and another oxygen is also lacking from another from one of the fatty acid tails, and it's a CH instead of a C double bond to O or oxygen. So it's missing, sphingomyelin basically is missing three of the oxygens, which is present in the other phosphatidyl molecules. So plasma membranes of eukaryotic cells has a mixture of different phospholipids. They also contain large amounts of alcohol, helping with membrane rigidity. So various molecules, proteins, etc., interact with these phospholipids, especially with the head groups, in various ways. Some membrane proteins only function in the presence of specific phospholipid head groups, such as enzymes that require particular ion or reactive part of the molecules of the phospholipids to work correctly, function. So molecules are specific to binding, so there's binding specificity, especially for enzymes and proteins, which are attracted to certain head groups exposed on the membrane's surface. So these lipid head groups are very important, and are in different concentrations based on the various functions on the cell membrane. We'll continue in the next part. Thank you.